Yo, word up, Mr. Ferrante here. This is problem 8 from the homework, and we're going to run through it. Please look at the video for problem 7 first, and then try problem 8 on your own, completely from scratch, the entire thing through, and use this video to check your work. Okay? So if you haven't done so, pause the video and do problem 8 on your own, then come back here and check your work. Welcome back. Here's problem 8 from scratch. The first thing we had done is we changed the problems from whatever variable they're using into y's and x's. So we said this one was y equals, instead of 3w squared, we said it was 3x squared minus 8x and then plus 4. So there's that guy. The 0 really is y when it's set to 0, but we're changing the problem back into its original parabola form. And here it is. All right, step 1, find the x-intercepts with the quadratic formula. I'm going to assume that you already have the quadratic formula, but now's a good time to test yourself. Go ahead and pause the video. Write down once again from memory, what is the quadratic formula? Write it down yourself. Welcome back. Here it is. X equals negative b plus or minus square root of b squared minus 4ac all over 2i. You've seen the video in class for that. There it is, quadratic formula in all its glory and greatness. For us, our a, b, c values are still the coefficients. Our a value is 3. Our b value is negative 8, including the negative. And our c value is positive 4. So for us, let's plug those puppies in. We've got, I'll start it up here. X equals negative, remember to use blank parentheses at first, plus or minus square root of, let's just fill in the template here, b squared minus 4 times a times c all over 2i. And we'll fill in the I in a second here. All right, a value, let's start with b. Our b value was negative 8, so we've got negative 8 inside the parentheses. B squared, so negative 8 squared, minus 4ic. I was 3, so we got a times c, then all over 2i, and I is 3. From here, simplify. Now you can see this is why I have you put parentheses here, because we have, it's not just negative b, it's the opposite of whatever b is. In this case, b is a negative, so if you do a negative negative, it turns this to a positive. So we've got x equals positive 8, because it's the double negative, plus or minus square root of negative 8 squared is positive 64, because that's a negative times a negative. And here we have a negative times a positive times a negative. Overall, that's a single negative. And 4 times 3 is 12, and then 12 times 4 is 48. So there's that dude. All over 2 times 3 is 6. Check. Then simplifying farther, this is 8 plus or minus square root of 64 minus 48. Off to the side here. 64 minus 48. That'd be 14, so it's 6. Borrow the 5. We got 16 left over. So 64 minus 48 is 16. All divided by 6. And the square root of 16 turns out nicely to be 4. So we have 8 plus or minus 4 over 6. And now we can branch off into 2 directions. So 8 plus or minus 4 all over 6 branches off into 2 possibilities. 1 for plus, 1 for minus. If it's plus, we've got 8 plus 4, then divided by 6. If we use the minus sign, we have 8 minus 4 all over 6. And calculating each case, 8 plus 4 is 12, and 12 divided by 6 is 2. So there's one possible x-intercept. In the other case, 8 minus 4 is 4, divided by 6 will reduce to 2/3. And that's our second possibility. So there we've got x-intercepts. Let me get my eraser out and erase stuff we don't need here. But our x-intercepts in their official forms are 2, 0, and 2/3, comma 0. And symbol, 2/3, comma 0. Those are our x-intercepts. Let me go ahead and erase this work. Next up is the y-intercept. Go back to video for problem 7, and remember there's a shortcut to finding the y-intercept. You could plug in 0 for x, but if you do plug in 0 for x, all that's going to be left is this last term. So in an instant, our y-intercept is 4, and written as a point, it's 0, comma 4. So there's 1 second problem. Finally, we've got line of symmetry and vertex. The line of symmetry equation is x equals negative b over 2a. We have to plug in our a and b values. So negative b over 2 times the a value. And for us, we said that the b value was negative 8. So that goes here. Our a value was 3. That goes there. And a double negative is a positive 8. Divided by 2 times 3 is 6. And so 4/3 is the line of symmetry. So x equals 4/3 is our line of symmetry. And then for the vertex, it's going to be at 4/3, comma something. And to find out the y-coordinate, we'll plug in 4/3. 4/3 also is 1 1/3. We'll do that later on when we plot stuff. But for now, let's plug in 4/3 for x. We got y equals 3 times, instead of the x value, we'll leave space to plug in 4/3, minus 8 times the x value, and then plus 4. Plugging in our line of symmetry, 4/3 in place of x. So we got 4/3 here, 4/3 on this guy. And remember, to square a fraction, you square the numerator and the denominator each separately. So we got 3 times 4 squared is 16, 3 squared is 9. Let's see, make this 8 over 1. That way there's a negative overall. 8 times 4 is 32. 1 times 3 is 3 on the denominator. And finally plus 4. Then taking this farther, remember you could do 3 times 16 and 1 times 9, but it's easier in this case. Since 3 can go into 9, I would do that first. So left over is 16/3. So we've got y equals 16/3 left over here, minus 32/3. This time I don't need to change things to the same denominator except for on this term. This guy, to change 4 into thirds, it's 4 over 1. So times by 3 over 3. To convert that to thirds, that's 12/3. And now that we have thirds for all 3 parts of the fraction, we can add them up. 16 minus 32 is negative 16. And then if we add 12 to that, plus 12, we get negative 4 overall. So this adds up to negative 4. That's cool. So that means the y-intercept is at 4/3, comma negative 4. So not as many fractions involved this time as last time. I'll erase this and we'll make a quick sketch here. For your graph, either use graph paper and do it nice and neatly on actual graph paper, or the back of the worksheet has some graphs. So let's draw for us a blank x-y axis. Check. There's my y-axis, x-axis, and let's plot. The x-intercepts are at 2, 0 and 2/3, 0. So here's 1, 2. There's 2, 0. 2/3 is 2/3 of the way to 1, right about there. Done. Next, the y-intercept is at 0, 4. And I can already see I'm going to run out of space here. But let's do it anyway. 1, 2, 3, and 4. There's that dude. 0, 4 is a y-intercept. And finally, the x line of symmetry is that x equals 4/3. 4/3 is the same as 1 1/3. So if I go over 1 and a third more, there's my vertical line of symmetry. That splits the parabola into two equal pieces. There we go. And here's our two x-intercepts that are the same distance from this line of symmetry. The y-intercept should also have a matching point over here. So there's the mirror image of the y-intercept. And finally is the vertex at 4/3, or negative, or part, sorry, 1 and a third. So it's along the line of symmetry, and it's down 4 spaces because the y-coordinate is -4. So we'll go down 1, 2, 3, 4, and here's our vertex. This is a pretty skinny parabola. Let's try to draw this neater than my last one. If you saw the video for problem 7, that parabola is pretty messy. This one's not that much better, but that's all good. So there's my skinny parabola. The fact that there was a 3 here made the parabola skinnier, and we'll study that in a different chapter. So there's my parabola, and I'll go ahead and make a video for problem 9 if you're lucky. But for now, have a great evening. Bye.